Alright, so I'm going to be going over this question here. You install conduit that runs 5 meters through an area that has an ambient temperature of 55 degrees Celsius. If the conduit contains 3 2-aught AWG RW90 XLPE 600 volt non-jacketed copper conductors to feed a 3-phase 3-wire load, what is the maximum current each conductor can carry? And what is the minimum size ENT conduit that should have been installed? So it's a two-part question. First, we're going to go over the ampacity question. So what is the maximum current each conductor can carry? So for this particular question, we're dealing with 2-aught RW90 XLPE copper conductors. It's running a conduit that are going to be experiencing ambient temperatures of 55 degrees. Alright, so those are my keywords there and what I got to keep in mind to solve this particular question. So for copper conductors, we're going to go to table 2 in the code book, and that's copper conductors going through a raceway. Going through a raceway or a cable where there's no more than 3 of them, with not having a rating more than 5,000 volts. Okay, so we know that we're dealing with RW90, and so we're going to be looking in the 90 degree column, and we're looking at 2-aught, and so if I cross-reference there, I know that that 2-aught cable is good for 195 amps at 30 degrees Celsius. Alright, so I'll write that down there. 2-aught equals 195 amps at 30 degrees Celsius. So because we're dealing with 55 degrees ambient air temperature, we need to use table 5A, which is going to derate it for any temperatures over 30. So I'm going to go back to my code here, and if I click on 5A here, it'll give me the correction factors applying to table 1, 2, 3, and 4, and 60 for ambient air temperatures over 30. So I'm dealing with 55 degrees, and I'm gonna mesh it with my 90 degree installation temperature rating, which is going to give me a correction factor of 76%, 0.76. And so I'm going to multiply my 195 by 0.76, which is going to give me 148.2 amps. So that is what my particular 2-aught cable is good for, because it's going to be running and being exposed to ambient air temperatures of 55 degrees Celsius. So it's good for 148.2 amps. So that's the first part of my question. The second part of the question is what size conduit, if I'm using ENT, would I need to have it installed in? So 2-aught's a pretty significant size, so my conduit's going to have to be pretty big, I would reckon. But using the Canadian Electrical Code tables, I am going to be using a series of 3 tables to figure that out. So I got to use table 8, and then I'm going to use table 10, and then I'm going to use table 9 to figure out conduit size. Alright, so let's take a peek at table 8. So table 8 is the maximum allowable percent conduit and tubing fill. Here I got insulated conductors and multi-conductor cables, not lead sheath. That's going to be the majority of the time. We're going to be using that part of the table here. And if I have one, I can fill that conduit up to 53%. If I got 2 conductors, 31%. Yeah, I got 3 conductors, so I know I can fill that conduit up to 40%. So I'm going to make note of that I can fill the conduit up to 40%. And that's going to be the majority of the time I can fill conduits up to 40%. Okay, next, I got to make note of the particular conductors I'm using. Now, a few other things I'm going to have to highlight here. I'll use a different color. Is I'm using 600 volt non-jacketed RW90 XLPE. All right. So I got to keep that in mind as I take a look at table 10, RW90 XLPE. Now, 10A is the table I'm going to be using. There's a few variations of 10. 10A is going to deal with stranded wire. Now, it doesn't mention that it's going to be stranded wire, but it's definitely not going to be solid. If we take a look at the solid table, 10C, well, that is only going to give me conductors in 3 different sizes, and it's definitely not going to give me a 2-aught solid copper conductor. So I can assume safely that it's going to be stranded. It's definitely not photovoltaic, and it won't be a DLO cable. So table 10A is what I'm using, and I know that I'm using R90 XLPE and that it was rated for 600 volts. Now the asterisk, we got to pay attention to that. The asterisk down here means unjacketed, and I know I'm using unjacketed as well. So I'm going to be using this first column here. If I scroll down here, I got 2-aught, and that's going to give me the cross-sectional area of each of those conductors with its insulation around it. So each individual conductor is going to be 141.9 millimeters squared. So I'm going to make note of that. 141.9 141.9 millimeters squared. I have 3 of them, so I got to multiply it by 3. It says here, conductors to feed a 3-phase 3-wire load. So I'm just going to multiply that by 3, which gives me a total area, 41.9 times 3, of 425.7 millimeters squared. So that's the total area that the conductors themselves are going to take up. Now I got to find a conduit that is going to be large enough so that those conductors only take up a maximum of 40% of its total cross-sectional area. So I'm going to have to make another highlight here. I am dealing with ENT conduit, and I'm going to have to find that from table 9. So I'm going to go back to my code here. Now I happen to know it's going to be table 9G. And up on the headings here, I got rigid, flexible metal conduit, rigid PVC, DB2, metallic liquid tight. And then at the end here, I got electrical non-metallic tubing, or ENT is what that ENT stands for. So I know that I got to be able to withstand 425.7. Obviously, my 357.42 or 35 trade size 35 is not going to be big enough, so I got to up it to trade size 41, which is going to be 491.91 millimeters. Now notice here that table 9G is dealing with these particular types of conduit, but also that I'm in the 40% fill. So this is a particular table that you're going to want to use if you're only able to fill that conduit up to 40%. In this case, I can only fill it to 40%, so I'm using this table. If we went up to table 9F, for example, or table E, well, again, I got electrical non-metallic tubing here, but it's going to give you that 31% fill. So it's taking the total area of the conduit itself and then doing the math for you and taking 40% of that total conduit area. And thus, trade size 41 is going to be big enough for this particular circumstance. All right, so that was 41. So trade size equals 41. Now, if I'm used to imperial measurements when it comes to conduit, as most people probably are, there is a conversion in the code book. So if we go to conduit tubing and fitting sizes, here in my index, trade size, or the metric designator here, 41 is going to equate to 1.5 inches. ENT. So I might make note of that as well. And that's how you solve ampacity of a conductor type question with its correction factor, as well as a conduit fill type question.